Did you know that the universe might not have started with the Big Bang at all? While we've been taught for decades that everything space, time, and matter burst into existence from a single fiery explosion, some of the most cutting-edge observations from the Webb telescope are flipping that idea on its head. The Webb telescope, our most advanced eye in the sky, has been sending back data that's left scientists blinking in disbelief. Instead of confirming what we've believed for years about the origins of the universe, it's, well, kind of throwing a wrench in the whole operation. The deeper it looks into the early universe, the more the old models, including the cherished Big Bang theory, start to look off. As in seriously off. Now, why does that matter? Because for nearly a century, the Big Bang theory has been the gold standard for how everything began. It's in the textbooks. It's in the documentaries. It's practically in the air we breathe when we talk about science. But Webb's findings are suggesting that it might be time to consider some new cosmic stories. So, let's rewind. The Big Bang, as we've understood it, wasn't really a Big Bang in the traditional sense. There wasn't an explosion in space. There was no space. Instead, space itself expanded outward from a single ultra-dense, infinitely hot point known as a singularity. That was about 13.8 billion years ago when not just matter, but time and space themselves were born. From this singularity, the universe began expanding, and it's still expanding today. We know this because of Edwin Hubble's mind-blowing discovery back in the 1920s. Distant galaxies aren't just sitting out there. They're moving away from us. That meant the universe was stretching out like dough rising in a cosmic oven. Scientists realized that if we play that expansion backwards, like rewinding the universe's life story, we end up at a moment when everything was crammed into that single incomprehensible point. This was the essence of the Big Bang theory. One of the key pieces of evidence supporting this model is something called the cosmic microwave background radiation. A faint glow left over from the early universe. Kind of like heat still lingering in a room long after the fire's gone out. This light is believed to have originated around 380,000 years after the Big Bang, and it still surrounds us today. The Big Bang theory never actually explains what happened at the very beginning. Not the true moment of birth, but everything that happened immediately after. We're talking fractions of a second, starting from what's known as the Planck time, about 10 cubed seconds after it all began, and going up to about 400,000 years later. Everything before that, still a giant cosmic mystery. Now, enter the Webb. The telescope has been peering so deep into space that it's essentially looking back in time, capturing light from ancient galaxies that existed not long after the supposed Big Bang. But here's the kicker. Those galaxies appear way too mature. They're bigger, brighter, and more complex than they should be if the universe was only just beginning to form structure. And this is what's throwing cosmologists into a frenzy. If these galaxies really did exist that early and with that level of development, it would challenge our most fundamental assumptions about how the universe formed and evolved. And just when you thought the Webb revelations couldn't get more mind-bending, guess what? They did big time. See, it's one thing when a discovery nudges at the edges of our understanding, but it's a whole different story when that discovery flat out refuses to fit anywhere within the current scientific framework. And that's exactly what's happening. Traditionally, astronomers believe the first stars lit up the cosmos around 200 to 300 million years after the Big Bang, marking the end of the Dark Age and the beginning of structure in the universe. But when and how did those scattered stars begin merging into proper galaxies? That part was still a bit fuzzy. Then came the game changer. In July 2022, Webb peered back in time and captured images of faint reddish glows initially thought to be small primitive galaxies from the earliest era of the cosmos. And sure enough, they matched expectations. At first, modest in size, not too dense, exactly what you'd anticipate for a universe just beginning to organize itself. But soon after, the curtain dropped on one of the biggest surprises in modern astronomy. Those little red dots. Not so little, not so primitive. In fact, they turned out to be fully formed galaxies, massive ones already thriving just 500 to 700 million years after the Big Bang. Let that sink in. They were already as large as our Milky Way during a period when the universe should have barely had enough material to piece together galactic infants. These ancient galaxies held more than 10 billion stars. One of them possibly over 100 billion. All packed into a time frame that, according to our models, shouldn't allow for anything like this to exist. To make this work within our current theories, the universe would have needed to be way more densely packed with matter than we thought, up to 5 times more, in fact. Either that, or we're missing some entirely new, unknown mechanism of galaxy formation that changed the cosmic game early on. But this wasn't a one-off anomaly. Not even close. As more data poured in, it became clear these weren't isolated quirks. Webb had opened the floodgates to a growing list of discoveries that challenged the very heart of the Big Bang narrative. More ancient galaxies way too mature for their age. Early supermassive black holes far bigger and more developed than they had any right to be. Elements detected in the early universe that, by all accounts, shouldn't have existed yet. And then there's the persistent mystery of the Hubble tension, the baffling discrepancy between how fast the universe is expanding in theory versus what we're actually observing. Put all of that together, and you're left with one undeniable truth: something doesn't add up. The standard cosmological model, the one built around the Big Bang, is cracking under the pressure of hard evidence. And just when you thought the questions couldn't get any deeper, well, the rabbit hole goes further than we imagined. Because while the Webb telescope is shaking the foundations of the Big Bang model with hard observational data, some scientists argue that the real problem lies even deeper. For them, it's not just that the Big Bang theory is incomplete. It's that it might be fundamentally flawed from the very start. Even among those who still stand by the Big Bang, there's a quiet but growing acknowledgement. There are massive gaps in this theory, especially when it comes to the biggest questions of all, like how did something come from literally nothing? And more unsettling, why did it happen in the first place? We're told that space, time, matter, all of it burst into being 13.8 billion years ago from an initial singularity. But that leaves us with the haunting question: what was before that? Legendary physicist Stephen Hawking had a rather poetic and controversial take. Asking what came before the Big Bang, he said, was like asking what's north of the North Pole. In his view, time itself was born at that moment. So there was no before to speak of. No need for a cause. No need for a trigger. It just was. But not everyone buys that. Many physicists are uneasy with the idea that a universe as complex as ours just popped into being without explanation and from absolute nothingness. And then there's another cosmic riddle: why does the universe look so uniform? No matter which direction we look, the large-scale structure of the universe, its density, its temperature, its radiation looks remarkably even. Galaxies are scattered across the sky in an eerily consistent way. To explain this, scientists proposed the cosmic inflation theory, a mind-blowing phase of hyperfast expansion that happened in the tiniest sliver of a second after the Big Bang. It's a clever fix, but also a hot topic of debate. Did inflation really happen? And if so, could it have gone even further than we imagined? Some researchers expanded on the idea of inflation and proposed something even more bizarre. What if inflation never fully stopped? This idea, known as chaotic inflation, suggests that while inflation ended in our region of space creating our universe, it continued elsewhere forever. In those inflating areas, new bubble-like universes could have formed, each with its own unique laws of physics. That would mean our universe isn't the universe. It's just one pocket in a multiverse of countless others, each one an entirely separate reality, each one with its own version of truth. Another theory takes a very different approach. What if the universe never really had a beginning at all? Enter the Big Bounce. Instead of a singular creation event, this idea suggests the universe goes through endless cycles, expanding, collapsing, and rebirthing again and again. The Big Bang we talk about today? That was just the latest bounce in a cosmic rhythm that's been going on forever. No absolute start. No absolute end. Just an eternal dance of death and renewal. It's almost poetic and totally flips our understanding of time, space, and destiny. And believe it or not, that's still not the full list of Big Bang alternatives. One older theory, which made headlines all the way back in 1955, claimed there was never a Big Bang at all. Instead, the universe has existed forever, with new matter constantly forming, giving the illusion that it's expanding. This steady-state model never caught on like the Big Bang did, but it's seeing a strange revival thanks to some recent observations. And then we tumble into the wildest theory of all. Some quantum physicists and string theorists are entertaining an idea straight out of a sci-fi movie. What if the universe we live in isn't real? Not in the way we think. Anyway, according to the holographic principle, everything we perceive might be nothing more than a projection of flat, two-dimensional surface encoding the information for a three-dimensional experience. In this version of reality, our universe is a kind of illusion, like a cosmic movie playing on an invisible screen. And if that wasn't surreal enough, there's the simulation hypothesis. What if our universe is the product of a hyper-advanced civilization? One that has the power to simulate entire galaxies, planets, and conscious beings. According to the Kardashev scale, a Type 3 civilization capable of harnessing the energy of an entire galaxy could potentially build such a simulation using a theoretical device called a Matryoshka brain, a massive, layered supercomputer powered by starlight. Yes, it sounds insane, but the math behind it, surprisingly solid. So, in the end, the Big Bang, once the untouchable cornerstone of modern cosmology, may just be one version of a far deeper, more mysterious reality. Whether the universe was born in a fireball, cycles endlessly through time, exists as one of many bubbles, or is simply a well-crafted illusion, one thing's clear. If you've made it this far, you're clearly as fascinated by the cosmos as we are. So, don't miss what comes next. Subscribe, join the conversation, and stay curious, because the universe is far stranger than fiction, and we're just beginning to understand its story.